Okay, in this video we're going to talk about the goal of science and then some consequences of the way we've been talking about science. So you might think the goal of science is to find theories that work well enough to help us accomplish various tasks. I don't think of the goal of science that way, but if you do, that's fine. Everything I say about science, like claims like there's no certainty in science, for example, will hold even if you think of the goal of science as merely finding theories that work well enough for us to get by. Other people say the goal of science is to show which theories we shouldn't believe, never to tell us what to believe. I think that view is implausible, and differences between that view and the view I sketched below are relevant. That is, what I say below won't always hold if you have this view that science only tells us what not to believe. But I'm just going to set that view aside because I think it's implausible and I don't think anybody actually takes it seriously in their heart of hearts. Why do I say that? Well, advocates of that view still believed scientific theories, right? Advocates of the view that you're only ever showing what not to believe still put forward theories. Well, they can't put forward theories if they think science is only showing you what not to believe. At any rate, I'm going to set that view aside, and I'll say this. The goal of science is to establish how probable any given theory under consideration is. So we can have probability assignments for theories. What does probable mean here? We'll come back to that in a minute. First, I want to note the following. Here are some important consequences of what we've said so far about thinking about science. For any scientific proposition P, challenging P by arguing that we aren't certain that P is true is deeply misguided. Now, why is that? Well, we said that there's no certainty in science, that the goal of science is not to establish with certainty that a theory is true, but rather to make a probability assignment to the theory, where the probability assigned is always going to be below 100%. Why is it always going to be below 100%? Well, because observation error is always possible, and because observation underdetermines theory, and theory underdetermines observation. So, again, for any scientific proposition P, challenging P by saying we aren't certain that it's true is deeply misguided. So if somebody says, but how can you be sure when you put forward a scientific theory, that's a bad way to challenge your theory. Because you can't be sure. Of course you can't be sure. It's a scientific theory, and it's part of what scientific theories are that you can't be sure that they're true. Similarly, for any scientific proposition P, challenging P by arguing that its negation is epistemically possible is deeply misguided. Why? Because of course its negation is epistemically possible. That is, of course you can imagine the theory being false, or you can think of it being false. After all, it's a scientific theory. If you couldn't even think of a scenario in which it's false, it wouldn't be science, it would be math or logic. Next, for any scientific proposition P, challenging P by arguing that we can't prove P is deeply misguided. Now, sometimes people use the word prove to mean something rather loose, like they'll say something has been proven when we have good enough reason to believe it. If that's the way you're using the word proof, then we often prove scientific theories. But sometimes people use the word prove in a more demanding way, in the way it's used in mathematics, especially think of geometry, where you do a proof by using transformation rules to move from a set of axioms to theorems, and you prove your theorems. But that's not how science works. Observations are not axioms, and the reasoning by which we move from observations to conclusions are not like transformation rules in geometry. It's all much looser. After all, in a standard way of thinking about geometry, I don't think this is the right way, but in a standard way of thinking about it, your axioms are sort of certain. You have direct intuitive insight that they're correct, and that gives them a kind of special kind of certainty. But observations aren't like that. We don't have direct intuitive insight into the way the world is. That's not how observation works. As we saw earlier, observation is your brain making all sorts of guesses to try and figure out, based on stimulus to your sensory apparatus, what the world is like. So for any given scientific proposition, challenging that proposition by arguing that we can't prove it is deeply misguided if we have this mathematical notion of proof in mind. So saying, but we can't prove that, is a bad way to raise doubt about a scientific theory. Now, what I want you to notice is people try and raise doubt about scientific theories this way all the time. So they'll say, well, has it been proven? Or they'll say, how can you be sure? Or they'll say, but you could be wrong. Well, anytime somebody says that about a scientific theory as a way to challenge the theory, they're just demonstrating that they don't understand the nature of science. It's in the nature of science that you can't be certain that the theory is true, that it's possible in an epistemic sense that you're making a mistake, that you haven't done a proof, because science isn't about proof in that mathematical sense. That's not the way science works. Now, to be clear, science is a miraculously successful and important way to learn about the world. So saying that it doesn't involve proof and it doesn't involve certainty isn't denigrating science. It's just pointing out a feature of the system. Okay. So finally, I want to distinguish between two different notions of probable so we can understand what we mean when we say that there's science aims to establish how probable any given theory is. There's a frequency notion of probability. So suppose I say there's a 50% chance that a randomly selected person is male. That's the frequency of males in the population. And sometimes when people talk about probabilities, including scientists, they're talking about those kinds of frequencies. But there's a very different way of thinking about probability, and that's as degrees of belief. So suppose I say there's a 50% chance that a certain theory is true. I'm not saying the frequency with which the theory is true is 50%. I'm not saying it's true half the time and false the other half. So what am I saying? I'm saying something about my degree of belief, my confidence, what's called a credence, how strongly I believe the theory. So I'm saying I would assign a 50% probability to it, not meaning it's true half the time and false the other half the time, but I'm saying something about my confidence in the theory. I'm 50% confident that the theory is true. So frequencies are often thought of as objective probabilities, and the base rates we looked at earlier were frequencies, how frequently the event occurs over time, how frequently babies are born female, how frequently does a fair coin land tails. Frequencies can be complex, they can be conditional, so we can consider how frequently one event corresponds to another over time. So we can ask, for example, how frequently does someone have cancer given that she tests positive? How frequently does someone have higher than a 3.7 GPA given that she scores perfectly on the ACT? Those are still frequencies even though they're conditional. But they're frequencies, they're objective probabilities. They're just sort of facts about the distribution of characteristics in a population. Sometimes probabilities are subjective. These are not frequencies. So when R2-D2 says the odds of Luke surviving the night are 725 to 1 against, he doesn't mean that on Hoth, this remote planet where basically nobody lived prior to the rebels, every 725 times somebody tried to sleep outside, only one survived. That's not what he means. It's not a frequency. It's rather his estimate of how confident he is that Luke's going to die. He really thinks Luke's going to die. So when C-3PO says the odds of successfully navigating an asteroid field are 3,720 to 1 against, again, that's not a frequency judgment. He hasn't measured people going through this asteroid field in this particular condition and found out that you only get one survivor for every roughly 4,000 attempts. Instead, he's saying, I'm very, very, very confident, and he's quantifying that confidence, but very, very, very confident that we won't survive. Spock has a nice one because it has a decimal. So he thinks the odds we both die are very, very small. And what he's saying is not that every time the captain and the science officer have done something like this, they've been killed with this frequency. He's just estimating, based on all sorts of information he has available to him, how probable he thinks the theory we will be killed is. So these are all subjective probabilities. Okay. Now, in the example of the kind of cancer cases that we looked at much earlier in the semester, when we asked questions like, what are the odds that I have cancer, given that I tested positive, we came up with an objective probability. But suppose you're not interested in the odds that someone or other has cancer given that they test positive. You want to know about yourself. You want to know what are the odds that I have cancer given that I tested positive. Well, there are certain facts about you that might be relevant. For example, you might have a strong family history of cancer, and that will raise the probability. Or you might have no family history of cancer. Or you might live a perfectly clean lifestyle, or you might live a terrible lifestyle. And all those factors are relevant to assessing the probability that you have cancer given that you test positive. But there isn't anybody with exactly the distribution of characteristics that you have. So it's unclear that you can really count on frequencies in that kind of case. So an estimate that you have cancer, given that you test positive, is likely a subjective probability. It's a confidence. So in these cases, probabilities are degrees of belief. They're credences. Okay, why call them subjective? To start, we have to ask where the sort of starting point for assigning probabilities come from. And the answer is they're based on everything you believe. So suppose we're considering some evidence that Wendy Winterstein told a lie. So here's something Wendy Winterstein once said roughly: "We left the American Association of Universities, that is Iowa State did, because their ranking system is unfair." And suppose the evidence, in fact, we likely left because we're going to get kicked out for various reasons. Suppose the evidence is that a friend told you that Wendy Winterstein was lying. And suppose the friend is usually reliable, but not always reliable, like she's 95% reliable. How are we to decide whether she's lying? Well, we can't just use the friend's judgment, because maybe, in fact, we have good reason to believe, independent of this, that Wendy Winterstein was telling the truth, or maybe we have good reason to believe, in fact, independent of this, that Wendy Winterstein was lying. We need to use all those factors. So suppose we have two different people here. One says, "I don't believe much about Wendy, but I know politicians are often dishonest and that high-level administrators in colleges are more or less politicians." So that's going to be a starting point for assessing the evidence from the friend saying that, Wendy was lying, and that person's going to think she's probably lying. But suppose instead we have B here who says, "I've always believed Wendy to be honest, and I don't have any opinions about administrators in general." Then B might be suspicious of the friend's report that Wendy is lying and think, okay, Wendy's telling the truth. The key thing here is that the starting point, the prior probability, that is, the probability you assign prior to the friend's testimony that Wendy was lying, for the theory might be high because you're like person A. Or it might be low because you're like, so although you don't believe much about Wendy, you believe that politicians are often dishonest and that high-level college administrators are politicians. Or your prior for the theory that she's lying might be very low because you're like B. You've always believed Wendy to be honest, and you don't have any opinions about administrators in general. These are both maybe reasonable positions, but they're very different positions, and the probability that A and B assign to the claim Wendy is lying will be very different depending on which starting point they have. So A and B can agree that the testimony is 95% reliable and still reach different conclusions because their starting points, their priors, are based on other things they believe, and they believe different things. And that's not all. They might have different beliefs about how reliable the testimony is, and they might have different beliefs about how probable the observation is. Obviously, each person should use what she believes to assign priors. What else could you do? Accordingly, the degree of belief that you should have in a theory might be different from the degree of belief that I should have in a theory. And that's why the probabilities at issue are subjective. It's not just that they depend on what we believe, it's that what we should think depends on, what probability we should assign depends on what we believe. Now, this doesn't mean that the truth of the propositions at issue comes in degrees. So truth does not come in degrees. Every proposition is true or false. Never both, never some of each, never to some degree. Rather, something mental, your confidence in propositions, comes in degrees. Confidence in the truth of propositions comes in degrees, and correspondingly beliefs can be said to come in degrees. How do degrees of belief work? Well, they're typically measured on a scale from 0 to 1, where for any proposition P, 0 is certainty that the proposition is false. So if what I said earlier about there being no certainty in science is true, we'd never reach that 0 level. 1 is certainty that that proposition is true, so we'd never reach that 1 level either. 0.5 to 1 is trending towards belief in the proposition, and below 0.5 is trending towards belief in the negation of the proposition. 0.5 is the point of perfect neutrality. Now, you could extend the range of neutrality. What I mean by that is, just because you're at 0.6 in a proposition doesn't mean that you have to believe it's true, and just because you're at 0.4 doesn't mean you have to believe it's false. For a variety of reasons, perfectly acceptable reasons, you might be sort of more cautious. You might demand 0.8 to decide that a proposition is true, or 0.3 to decide that it's false. There can be individual differences just based on how, whether you're a cautious or a more reckless person. The only thing that's objectively true is that 0.5 has to be neutral. Above 0.5 can't be disbelief. It has to be trending towards belief. And below 0.5 can't be belief. It has to be trending towards disbelief. Okay. Some crucial questions left on the table, which we will talk about going forward. What is explanation? When does an observation confirm a theory? So how does confirmation and disconfirmation work? And correspondingly, how can we assess the overall probability of a theory? And we'll talk about those questions in future videos.